Okay, in this video I want to look at a solution of one of the GCSE exam papers from CCEA exam board, which was on a new GCSE, took place on 2nd of June. To find the exam paper, you can go to the link in here on the Maths Raven website, and you can choose the higher tier, Unit T6, Paper 1, and this is a non-calculator calculator exam. I'm going to start this by going to the next page. The first question says w equals 5x minus 2y squared z. Work out the value of w if x is 5, y equals to minus 3, and z equals 4. So you just need to replace the x, y, and z. So w would be equal to 5 times 5 minus 2 times y squared minus 2 to power of minus 3 to power of 2, and times z, which is 4. Again, do focus in here. When we have a minus number, we need to put it inside the bracket. There's a difference with and without a bracket. There's a video that you can refer on this done before. We also need to look at both maths in here and prioritize the timing and dividing first, and also this square, because that is like other. So minus 3 squared would be 9. 2 times 9, 18. 18 times 4 is 72. And this side we have 5 times 5 is 25. So 25 minus 72. And the answer would be minus 47. So the answer would be minus 47. So I'm just going to write the answer in here. The second question says, explain why two of the shapes below have an area of 66 centimeter squared while the other shape does not. So if you look at the first shape in here, this is a trapezium, because we have that side and this side, they are parallel. So trapezium definition is that we have it has two parallel sides. So when we look at the surface area of a trapezium, it is average of two bases times height. So in here we have 15 and 18 as a base, the sides that they are parallel. So average of that would be 15 plus 18 divided by 2. That is a average of base times height, which is this 4 in here. So that would be times 4. So if you look at here, 2 and 4 simplifies. That would be just 2. 15 plus 18 is 33 times 2 is 66. The second shape is a trapezium. Basically we can, before going to I'm going to put that centimeter squared just to show that that's the surface area. For the second shape, we have trapezium, and that is one side times the other side. It's like a rectangle. So this is 11 times 6 would be 66, again centimeter squared. And the reason this is like a rectangle is that if you put lines like this, this one in this small triangle here is equal to that triangle there. So instead of having a whole trapezium would be equal to looking at a triangle that is, if I just put a different color in here, that is in here. So this is equivalent to the area of a triangle, because those two small right angle triangles are equal. So that is 66 centimeters squared. When we come to the last one, again we have another trapezium. The reason that's a trapezium, again we have two sides that are parallel. and they are parallel because we see that both of those lines are 90 degrees with a horizontal line. So average of two bases times height again, so we have 3 plus 8 divided by 2 times height times 12. 12 divided by 2 would be 6 in here. 3 plus 8 is 11. 6 times 11 is 66 centimeter square. So explain why two of the shapes below have an area of 66 centimeter square while the other shape does not. Okay, looking at this on all of the three shapes that we have in here, we have the 66 centimeter square as a surface area, and the shape A and shape B, shape C, they are both trapezium, and it is very clear that they have two parallel sides opposite, because those two parallel sides are right angles to a single side, which basically makes them parallel. The only shape that it could look a bit more complex is the middle shape, which I'm going to draw that in here and discuss again that one through here. So we have a shape which is 11 and 11 centimeter and 6 and 6. For that shape, we can prove that this is a parallelogram. So why that is the case? So I can put a line in here between these 2 points, and we can say that this side is equal to this side equals to that, and this is shared in the middle. So those two triangles are equal. Therefore, we can find that this angle, which is opposite to 6, equals to this angle. And in the same way, we can find out that if we do it in different way, we can find out that also, if I look at this, so if this angle and that angle are equal, if you like, we can say that for between these two lines, we have a line that passes through those two, and basically alternate angles are equal. Then we can say that if this angle and this angle equals, and we see that the line is passing through these two lines in here, we can say that this line and this line are parallel. In the same way, we can draw another line in this side and say if we have a 6 and 6 and 11 and 11, we can prove that again this triangle equals to this triangle in this side, and then therefore this angle, or I can basically put it this angle equals to this angle. And if that is the case, we can say that this basically line, again, because their alternate angles are equal, therefore those two lines are parallel. So this can be proved to be a parallelogram, and for a parallelogram we have basically a times of two sides, as I mentioned. 11 times 6 equals 66 centimeters square. So I haven't seen any mark scheme for this paper, but I will leave this question at this point, and I will update if there was any mark scheme, and there could be issue with this question in this exam paper. So if I go to the next question, describe fully the single transformation which maps triangle A to triangle B. If you look at here, this side is mapping to this side in here, and if you look at the points, this point is mapping to this point, and this point is mapping to this point. So as we can see, if those two mapping there, therefore this point also mapping to this point. As we can see a reflection happening around the middle way up between these two shapes. So if this is in here, from this point to this point is 1, 2, 3, 4, 5, 6. So the middle of that is 3. So the line in between is this one in here, which is line of x equals 1. So we can basically say that this is a reflection around x equals 1, around line of x equals 1. Now going to the next part, draw the image of triangle A after a rotation of 90 degrees anti-clockwise about the point -1 and 3. So I'm just going to clear this parts just for us to have another sort of clean board to discuss what to solve the second part of the question. So first of all, we need to find out where is the point of -1 and 3. So -1, 3, -1 x, and 3 is y, +3. So this would be point of -1 and 3. And we want to have an image of triangle A after rotation of 90 degrees anti-clockwise. So if we look at this point, we need to connect it to the line, to the point that is rotating around, and then we need to do a 90-degree anti-clockwise rotation. So if we look at the 90-degree, this would come around here, and that point would basically transfer to this. So the point -1 and 1 would be transferred to point 1 and 3, 90 degrees around -1 and 3. So do have attention in here. You see this two size of the 2 equals to the size of 2 in here, so that is important to consider. And the same thing we would basically do maybe the next time we look at this point, we connect that to again the point, and we need to make it 90 degrees. You either need to measure this 90 degrees, or a trick in here is that when you consider from this point to this point, which is a rotation center, we are one positive in x, and we have 1, 2, 3, 4, 5 positive in y. So this line is basically 1 positive x and 5 positive in y. So we need to do this other way around. So for that rotation, we are going to do 5 in x. So 1, 2, 3, 4, 5, and then we do 1 negative y. So this point in here, basically it is a rotation of that point around -1 and 3. Okay, and finally we can connect that point in here, and considering that we already have 2 points in here, we should be able to see that from this point going to our rotation center is 1, 2, 3 positive, 1, 2, 3, 4 negative. So sorry, 1, 2, 3 x and 4 positive y. So we need to go 4 in x. We need to change the location of x and y. So the numbers of x and y. So we go 4 in x, and we come 3 in negative y. So 1, 2, 3, that would be this point. Now if we connect all these 3 points together, we will have the transformation of that triangle around point -1 and 3 and 90 degrees anti-clockwise. Okay, so we're looking at the next question. The diagram shows a pointer which spins about the center of a circle disk. The disk is divided into sectors which are colored yellow, green, red, and blue. When the pointer is spun and it stops on one of the colors. So the probability of that, it will stop on red, blue, and green has been given. Jonathan is going to spin the pointer. Work out the probability that the pointer will stop on yellow. So probability of the red in here is 0.19, and the blue is 0.22, green is 0.27. So the probability of the whole this circle, which includes all of the event, is 1, because that includes every event. So probability of the yellow would be 1 minus 0.19 minus 0.22 minus 0.27. So if I add these together, so 0.22 and 0.27 is 0.49, and 0.19 adding to that 0.68. So this would be 0.32. So the answer for the first part is 0.32. Work out the probability that the pointer will stop on red or green. Red or green. So this is about a part that the part that's acceptable for us is this part and that part. So the probability of red or green would be 0.19 plus 0.27, because both of these are acceptable. So if we add these together, we will have 0.46. Okay, so this is the answer for this question. It wasn't a very difficult question. We go to the next one. Lucy has a bag containing 5p and 20p coins. The ratio of the number of 5p coins to number of 20p coins is 5/4. Work out the ratio of the total value of 5p coins to a total value of 20p coins and give your answer in its simplest form. The simplest form to consider this question is that when we say the 5p coins, ratio of 5p coins to 20p coins are 5/4, we could consider that we have 5 of 5p coins and we have 4 of 20p coins, because the ratio of the numbers of the coins is 5/4. Now, how much is 5 of 5p coins worth? So that would be 5 times 5 would be 25. And how much 4 of 20p coins worth? And that's 4 times 20, which is 80. And now it says work out the ratio of total value. So these are the values that are in here, and we need to work out the value of the 5p's to 20p's. So the ratio would be 25/80. And if I simplify this, divided by 5, both of them, both sides, numerator and denominator, 5 divided by 16. And I can simplify more, so the answer would be 5 to 16. So don't forget in here, when we write a fraction form of 5 to 16, it is same as writing in this form of 5 to 16. So that's the same thing. Fraction does represent the ratio. Okay, looking at the next part of the question, is John and Mark share an amount of money in the ratio of 5 to 6. Mark's share, so when we read this question, you need to be careful. John and Mark share. So John is 5 and Mark is 6. The question, you need to look at the people, the names and the ratios respectively in the question. Also for these questions, it is normally good to have put basically a word in here respectively, just to show that that is the case. So Mark's share is £48. What was the total amount shared? So Mark's share is £48. What is the total amount shared? So we have again 5 to 6, and 6 is Mark, and 5 is John in here. So the share is 5 to 6. We have Mark's share is 48 pounds. So if I know that in here the ratio for Mark is 6. So if I divide 48 to 6, which would be 8, this 8 pounds is a value of each one share. So that is the value of each one share. But in total, we have 5 shares for John and 6 shares for Mark, which 6 times 8 was giving 48 pounds. So what is the total amount shared? So that would be, in total we have 11 shared. So each share is 8 pounds. So that would be 8 times 11, which would be 88. So the answer for this question would be 88 pounds. Okay, we move to the next question. The length of a rectangle is 3 times its width. So the width is W, so the length is 3 times of that. So we need to write 3W because it's 3 times of the width. Write down a formula for the area of a triangle in terms of W. So the area of a triangle is length times width, so it would be W times 3W. So the answer would be 3W squared. So the answer here would be 3W squared. The area of a rectangle is 48 centimeters square. Calculate the width of the rectangle. So we know that now that the area is 48 centimeters squared. So we also know that algebraically the area was 3W squared. So we're going to say 3W squared equals 48. Dividing both sides by 3, W squared would be equal to basically 18 times 3 is 6. And 16 in total. So, and W from here would be 4, square root of 16. And just pay attention in here in algebra when we say W squared equals 16, and when we square root, we should say W equals plus minus 4, plus minus square root of 16, because minus 2 times minus 2 still gives minus 4 times minus 4 still gives plus 16. So that is still an answer. But in here, because we are talking about widths of a shape, we say that this minus number is not acceptable. So that is why in here, W equals 4, I just put a positive value. So W equals 4, and we know that the width is W centimeter. So, and we are saying that calculate the width of the rectangle. So therefore, width of the rectangle equals to W. So the answer it would be 4 centimeter. Be careful in here. If the question was saying that find out the length of the rectangle is 3W. So we have a W equals 4. Then we need to say 3 times 4 is 12, and the length would be 12 centimeter. Okay, so we move on to the next question. Complete the boxes in here. 2xy over 3y times a fraction gives 4xy squared over 9xy. So 3y times what would give us 9xy. So the answer would be 3 times 3 would be giving us 9. We already have the y there. We need to add another x. So 3y times 3x would be 9xy. In the numerator, 2xy times what gives 4xy squared. So again, 2 times 2 gives 4. We already have the x, and x has gone this side, and we have y in here. So 2xy times 2y would be 4xy squared. So in idea in here is that we should know that when we time two fractions together, for example, fractions like this, we are timing the numerator to numerator and denominator to denominator. So 2 times 2 is 2, 3 times 4 is 12. So in the same concept, you need to work out algebraically and basically find out what is time what gives basically the answer. Okay, so the next question here, find the reciprocal of 2.5. 2.5, basically we can write it as 5 over 2 because that's half of 5, and reciprocal of that is 2 over 5. Reciprocal of a fraction is changing the position of the denominator and numerator. Okay, so we go to the next question. Now it says rearrange p equals 2q minus 5r squared t to make r the subject of the formula. It says quality of the written communication will be assessed in this question. So we need to have the details in here. So we have p equals 2q minus 5r squared t. We want to make the r subject of the formula. I could, in here, I could basically do a minus 2q from both sides. So minus 2q from both sides. So if we do minus 2q from both sides, this side we will have p minus 2q equals 2q minus 5r squared t minus 2q. And minus 2q basically simplifies, so we have just minus 5r squared t. And now to make the r subject, I want to look at what is r squared. To keep this r squared in here, to have just r squared in the right hand side, I want to look at basically divide to keep this just to have just r squared in the right hand side. The remaining elements are in here are minus 5t. So if I divide both sides to minus 5t, so I put it into bracket because we are dividing to minus 5t. So this would be p minus 2q divided by minus 5t equals r squared. Now we have the r squared in one side, and then to have the r, we need to square root both sides. So when we square root, okay, we are going to square root both sides. So what will happen is that r equals plus minus square root of p minus 2q divided by minus 5t. This plus minus, that is exactly the same as the point that I just explained a few minutes ago on another question. When we square it, the answer could be minus or plus, because minus times minus gives a plus value. And this should be the will be the answer. Generally, this sort of questions are based on adding, subtracting, dividing, or timing both sides of equation to a value where we could simplify and basically make a parameter subject. Most of the time, if we have just one parameter here, same as this question, we are trying to reach to just this parameter. So we have to first move this to the other side, and then divide to minus 5t to also move them to the other side, and we will have just r squared equals that, and then we just square root it to find what is r. Okay, so I write the answer in here, so that will be plus minus square root of p minus 2q divided by minus 5t. And as you can see in here, that p minus 2q divided by minus 5t, it is not simplified further than that. Otherwise, we would need to simplify that part. Okay, we go to the next question. In the diagram above, ABC and AED are straight lines. So we are saying that this is straight lines in the sides. And EB is parallel to DC, EB is parallel to DC. And then we have AB equals 10, EB equals 7, and BC equals 6. And these are all shown on the image. So the question is, work out the lengths of DC. So this is a very typical triangle similarity questions. So we know that EB, is parallel to DC. Yes. By knowing that parallel, we can say that corresponding angles in here. If you look at here, if I continue these lines, what you see, you see that there is a line in here that is intersecting two parallel lines. So this line is intersecting two parallel lines, and that line the same. So if you look at if they are parallel, the corresponding angles, which is this and that, are equal, and this angle equals to that angle. Okay, to be in a more basically, we can write in here corresponding angles. And we can therefore say that angle ABE, I'm just going to clear this section just to so that we can see it better, but that was just explaining why this is the case. Angle ABE equals angle ACD. And in the same way, we can say that angle AEB equals angle ADC. By saying that, we also know that if we wanted, we can say that angle A in there is common between triangle AEB and ADC. So we know that we just need two equal angles for us to be able to say that two triangles are similar, which is the most important similarity condition. Mainly, most of the time, we have this two angle equal. So we have already proven that two angles are equal. We can say basically triangle AEB is similar to triangle ADC. Yes, so we have proven that these two triangles are similar. If they are similar, we can say that the ratio of their sides are also equal. So ratio of their sides, we would write that AE over AD equals EB over DC equals AB over BC. Okay. Now, these are equal. Then based on what we have, I'm just going to put some numbers to see which one of these values do we have in here. So EB is 7. So this one in here is 7. And AB is 10. AB is 10. So this is 10. Also, we can say from here that AC is 10 plus 6, which is 16. So AC. So if I just look at, maybe I have done a quick, a small mistake, AE over AD, EB over DC, and AB over AC. So yes, this is, I need to correct this one in here. Okay, so this is AC. Okay, so that's AC, and the value of that AC is 10 plus 6, which is 16. Now, our unknown is DC. And as you can see, we really don't need this part of the question because we don't have them, and we have not been asked to find anything about AE or AD. But if I now write just this section that we are basically more interested in this equation, separately, is that 7 over DC equals 10 over 16. Okay, 7 over DC equals 10 over 16. So we can basically cross multiple this. If we have any form of A over B equals C over D, we can always cross multiple, means that this A times D equals C times B. So we can say that AD equals CB. So just remember, it is not that difficult to prove. Basically, you are timing both sides of this to BD. So BD is the time of the denominators. And after simplification, you will find that you will get AD equals CD. So if I just do a cross multiplication in here, so that would be 7 times 16 equals 10 times DC. And from that, DC would be equal to 7 times 16 divided by 10. Okay, 7 times 16 is 112. 112 divided by 10 would be 11.2. So the answer would be 11.2, or I can write it in here, 11.2 centimeter. Okay, so that is the answer for this question. We move to the next one. Question 11, there are 12 socks in a drawer. 7 of the socks are black, 5 of the socks are white. Stefan takes at random 2 socks from the drawer, one after another, without replacement. So this is important, without replacement. So you need to look at those keywords. Complete the probability tree diagram below. So first time that Stefan takes socks out of the drawer, there is 12 socks in drawer, 7 of them black and 5 of them white. So what is the probability of that being black? Is 7 over 12. And what is the probability of being white? And that is 5 over 12. Now, we come to the top 3 first. So just imagine that Stefan has taken a black socks out of a drawer, and he wants to do the second socks. So what do we have now in basically this point? We have 6 black socks left inside drawer and 5 white socks left inside drawer. So when we take the second one, the probability of black is 6 over 11 and white is 5 over 11. Now, if you look at the second branch, in this point, because we have already taken another white out, we would have 7 blacks and 4 whites. So the probability of black would be 7 over 11, and probability of the whites would be 4 over 11. Now, so this is completing the probability tree here. The second part of question says work out the probability that Stefan takes 2 socks of the same color. So two socks of the same color, that basically means that this could be black and black, which means this line, and it could be white and white, which is this line. As you know, when we work with a probability tree, we time each branch, and we write the probability of the total of that branch at the end. So 7 over 12 times 6 over 11. So I'm just going to write it here, 7 over 12 times 6 over 11. That is the probability of having two black socks taken out of the drawer. So 11 times 12 is 132. I think we could simplify this in here rather than timing a large numbers. 6 divided by 6 is 1, 12 divided by 6 is 2. So that would be 7 over 22. Now coming to the white branch in here, this probability is 5 over 12 times 4 over 11. And that again can be simplified. Divided by 4 is 1, divided by 4 is 3. So the probability of two whites is 5 over 33. Now, probability of having two socks of the same color is basically is this plus that, because it doesn't matter if we have two blacks or two white. Both of them satisfy the sentence of saying that the two socks that they came out of the drawer have the same color. So the final answer would be 7 over 22 plus 5 over 33. And we need a common denominator here, and that common denominator is 66. Divided by 22 is 3. 3 times 7 is 21, plus 66 divided by 33 is 2, times 5 is 10. So that would be 31 over 66. So the answer would be 31 over 66, and this is the final answer because we cannot simplify this further. So we go to the question 12. The graph of y equals 2x squared minus x minus 3 for x between minus 2.5 and 3 is shown below. Now, so the question says, use the graph to solve the equation 2x squared minus x minus 3 equals 3 minus 1.5x. So if you look at here, the point of this question is that this section of the equation 2x squared minus x minus 3 is exactly same as here, 2x squared minus x minus 3. And we want to equate that to another equation, the other side, which is 3 minus 1.5x. So this basically means that if we assume that we have two functions of y equals 2x squared minus x minus 3 and y equals 3 minus 1.5x, the solution to these two equations are when we equate, because by substitution we can equate now the y from the top to the bottom, we can say that 2x squared minus x minus 3 equals 3 minus 1.5x. So in a way, the solution to that top equation is where this function intersects this function. Okay, when that function intersects the second function. And we already know and have the drawing of 2x squared minus x minus 3 because that is what we have been given between minus 2.5 and 3. We only need to draw this y equals 3 minus 1.5x. So to draw that one, we know that this is an equation of a line because it's a linear. It's just x, no x2s, no x cubes, and it's just x. we can just have 2 points to consider. We can have a table in here, x and y. If we give x equals 0, y would be equals to 3. And if we give x equal 2, we will have y equals 0. Okay, so you just need to be these cases a bit smart when you choose the numbers to make it a bit simpler. We see in here 2 times 1.5 gives a whole number. 3 minus 3 is 0. So that basically gives, these are giving us a simpler, basic simpler points. So I'm going to put the point of 0 and 3. So 0 and 3 is a point in 3 just around here. That is point 0 and 3. And a point of 2 and 0. And point of 2 and 0. So 2 is x and y is 0. So we have 2 points there. So if I now have the basically this my if I put a ruler there and try to connect those two. So I'm just going to try to set this ruler so that it is about right a bit more. So I'm just going to set this so that we have about almost accurate answers, because it's a graphical method, so it is important to do this about right. So if I just put this, connect these 2 points, and this would be the equation of the line that basically we have. So I'm just going to close both of these, and we will basically continue from there. So equation of line, we have the connection points, which are this. Okay, I basically do this bit of, I need to put it on a point wise. Okay, so we have a connection point this and connection point in here. So we have intersection of this function, which is y equals 2x squared minus x minus 3, and this line, which is y equals 3 minus 1.5x. Okay, so if we look at now here, we can now find out what are the coordinates of those 2 points. So the coordinates of those 2 points are basically looking at here. Because it's a graphical, we are just going to give an approximation value. So we have somewhere around minus 1.9. So x equals minus 1.9, and the y of that point is somewhere around 6. I'm just going to simplify. So this is 6. And then intersection of the other one in here is this point in here is 1.6, and y is around 0.6. So x equals 1.6 and y equals 0.6. Okay, so because we are looking just to the solution of the x values, so the answers for x are only the values of x equals minus 1.9 and x equals 1.6. So x equals minus 1.9 and another x equals 1.6. So we could have 2 answers in here. And this is an estimate because this answer is coming from a graphical solution. But if we wanted to find an exact answer to this solution, to this problem, we should take the right hand side to the left hand side, and we would make a quadratic equation, and we solve that. So if I just show that in here, just to see and compare, if I take the right hand side to the left hand side, I will have 2x squared. We have a minus x, and minus 1.5x coming to the left hand side becomes a plus, so that would be plus 0.5x, and we have a 3 on the right is positive, coming to the left is again minus 3 would be minus 6 equals 0. I timed this by 2 to make a whole number for this equation, so I will have 4x squared plus x minus 12 equals 0, and the solution for the quadratic equation would be x equals minus b, which is minus 1, plus minus square root of b squared, which is 1 squared, minus 4ac. So because that's minus 12, I'm going to minus would be plus. I'm going to write it plus 4 times 12, and that is divided by 8. 4 times 4 is 16. 16 times 12 would be 192, and 192 plus 1 is 193. So basically the answer in here would be minus 1 plus minus square root of 193 divided by 8. I just want to do one of the examples on my calculator to show the difference on a graphical and exact solution. So if I do square root of 193, and if I do minus 1 divided by 8, so what I get is 1.611, which is the exact solution, plus 1.611. And if you see in here on a graphical solution, we have got 1.6. So that is a good estimation that, and shows that we have done really good lines in here. We have our drawing into a scale, and that is important to get a better accuracy on a graphical methods. So I would leave the next one to you. If you do minus 1 minus the square root of 193 divided by 8, you should get somewhere around minus 1.9. Okay, when we move to the next question, which is question 13. This question says work out and simplify square root of 3 plus the square root of 27 to power of 2. So we can write basically square root of 3 plus square root of 27 times square root of 3 plus square root of 27, because that is what is the meaning of a power. And that is we need to time these together, so that would be timing that to this and in this form. So square root of 3 times square root of 3 is 3. Square root of 3 times square root of 27 would be square root of 81, which would be plus square root of 81 is 9, again plus another 9, and then plus square root of 27 times the square root of 27, which is 27, and the whole answer is 18 plus 3 is 21 plus 27 is 48. Okay, so another way of doing this is for us to know that square root of 27 equals square root of 9 times the square root of 3, which is equal to square root of 9 is 3, so that would be 3 square root of 3. So when we say square root of 3 plus square root of 27, we can say that square root of 3 plus 3 square root of 3 to power of 2, and that is 4 square root of 3 to power of 2, and that would be 16 times 4 squared times square root of 3 squared, which is 3, and the answer still is 48. But I have seen on for many students, when they look at a question like this, they basically look at a case of writing square root of 3 to power of 2 plus square root of 27 to power of 2. That is a really bad mistake, and many students do. We can never write for something like a plus b squared, we can never write this is equals to a squared plus b squared. This is completely wrong, and you need to look at completely writing a plus b squared equals a plus b times a plus b, which you will have some more extra terms. Okay, the next question is bracket 6 minus the square root of 5 times 3 plus 2 square root of 5 equals a plus c square root of 5, and find out the values of a and c. So again, I'm going to time this as same as above. So 6 times 3 is 18. 6 times 2 square root of 5 would be plus 12 square root of 5. Minus the square root of 5 times 3 is minus 3 square root of 5. Minus the square root of 5 times 2 square root of 5. Square root of 5 times square root of 5 would be 5. 5 times 2 is 10, and we have a minus, which would be minus 10. So if we simplify this in here, if we simplify that, this would be 18 minus 10 is 8. And 12 square root of 5 minus 3 square root of 5 would be plus 9 square root of 5. So if we compare this to a plus c square root of 5, we will find that value of a is 8 and value of c is 9. Okay, we move to the next question, question 14, which is the final question in this exam paper. A solid metal cylinder has a base radius of 3x. So I want to draw this, and we have a cylinder, and the radius of the base is 3x, and the height is 32x. The cylinder is melted down and made into a sphere of radius r. So we have a sphere in here that has radius r. All lengths are in centimeter. So we have everything is a centimeter, so we don't need to be worried about the units. Find an expression for r in terms of x. The critical point about this question is that the volume of this cylinder would be equal to the volume of that, because they both would have the same material, same amount of material. So we are just melting the cylinder and making it into a sphere. So the volume still is the same, it's not changing. So if I look at the volume of the cylinder in here, volume of the cylinder is a base times height, surface area of area of a base times height. So the base is a circle, so that is a pi r squared. So that would be pi times 3x squared, that is the surface area of a base, times height, which is 32x, so times 32x. And if we algebraically simplify this, we have the pi. Now, when we do 3x squared, this is inside the bracket. So you have to square the 3 and square the x. So really what you have in here, it's the 9x squared. You need to square both of them because both of them are squared. Both of them are inside the bracket. And you need to put the bracket. Do not forget to put the bracket there because we are talking about radius squared. So radius is 3x, and that is what is squared. Okay, so looking at here, and 9 times 32 is 288, and we have the pi, so 288 pi, and we have x squared times x would be x cubed. And there's no wonder in here that we have x cubed, because we are calculating volume, and x is the length, and the volume is centimeter cubed, so it has to have x cubed in it to make that centimeter cube happen. Now, we are going to say that the volume of the sphere is exactly the same as volume of the cylinder. So we know that volume of a sphere is 4/3 of pi r cubed. Okay, so this is being given in the formula sheet. You need to make yourself familiar with what is in the formula sheet in the exam, and refer as and when you need this. And we know that the volume is equal to the volume of the cylinder, so we can write 288 pi x cubed equals 4/3 pi r cubed. So there are some simplifications that we can do from both sides. Dividing by pi, we can simplify the pi and pi there. And we can time both sides also to 3 to remove that fraction element there. And we can divide both sides by 4. If I divide both sides by 4 first, so this would be 1. 288 divided by 4 would be 72. Now, timing everything to 3 both sides, we will have 3 times 72 is 216. X cubed equals r cubed. So if you read the question again, it says find an expression for r in terms of x. So basically what we need to do in here is √3 of both sides. So r in here would be equal to √3 of 216 x cubed. So we know that √3 of x cubed is x. But what is is there any √3 for 216? So 216, we can say that that is 5 to power of 3 is 125. 6 to power of 3 is 36 times 6, which is 216, which is exactly the answer. So if you like, √3 of 216 is 6. So the answer in here would be 6x. So r would be equal to 6x. So this is end of this exam paper, apart from question 2, which was not clear, and I could update when I find a mark scheme for this. All of the questions are described and discussed basically in detail. I will look at solving more exam papers on the new GCSE exams that happened in May and June. Do subscribe to the channel for updates and support, and put your comments and requests on the videos, and I will look at basically doing some of the requests on the topics or exam papers from you.